Okay, so in today's session, we
I'm
are,
not getting, sorry to interrupt, ma'am.
yeah.
Uh, in my calendar, I
Hmm.
can't see any means other subject doubt class like CT or statics or English. Only mathematics I can see. Is
If
there
you
any
are
problem
registered
with
and you are
my?
not able to see, please write to support. So any kind of issues you are facing like this, you have to write an email to support.
Okay, thank you. I messaged means I did means I mail
All
and
right.
I was there,
So in
but they
today's
did
session,
not
we are going,
respond.
if you are writing a mail to support and still you are not getting a response, it should not happen. You can send an email again to support. Definitely, you will get a response.
Okay, ma'am.
Yeah. All right. So today's session, we are going to see few problems from week 4. Okay. So most of the polynomials, most of the questions are based on polynomial functions. Okay. So the first question here you are having is that by dividing a polynomial p of x with another polynomial q of x, we get h of x as the quotient and r of x as the remainder. Right. So this is what usually we are having. Now, this is the quotient, this is the remainder. So, what is the relation between their degrees? So, mainly they are asking about the minimum degree and maximum degree of r of x. Okay. So, take any polynomial, not just r of x. For any polynomial, what can be the minimum degree?
1.
1.
Yes. Right. So, 1 is the minimum degree. What about 0? Can 0?
Ma'am, for the constant polynomial, it is 0 also because,
Yes.
for example, it is 3. So
Exactly.
the degree
Exactly.
of 3 is 0, ma'am.
Yes, exactly. So suppose if r is equal to 0, can the remainder be first of all 0? Can
Yes,
the remainder?
Yes,
Yes.
ma'am, remainder can be 0.
Okay, if r of x is 0, then what is the degree?
0.
Are you sure? If r
No,
of
ma'am,
x,
degree is 1.
if r of x is equal to 0, what is the degree? Are you sure?
X raised to 0 is 1. So degree 0.
If it is any constant but not 0, then what you're saying is fine. But when your constant is 0,
Yeah, I mean, if it's 0, then there's no degree. So
yeah, so the degree is not defined. If r of x is just 0, then the degree is not defined. So if r of x is any constant polynomial, then in that case, the degree is 0, right? So can
Yes, ma'am.
r of x be any constant polynomial? Yes,
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 right?
ma'am.
So in that case, can we say that the minimum degree is 0? Yes, because what is the relationship we know? We know that what is the relationship between r of x and p of x? The degree of r of x and degree of p of x. What do you know? Which one is always smaller and which one is bigger?
Px will be always greater.
So
Greater.
this is greater or equal to in fact, right? And
Yes.
what about the relation between degree of r of x and degree of q of x?
R of X will have
Q of
1
x,
degree less
Q
than
of
Q
x
of
must be
X.
lesser than R of x, ma'am.
Come on, are you sure?
The quotient, no, no, ma'am.
Quotient have higher.
R of x is lesser only. The dividend should be more.
Yeah, okay. Okay. Another question. What is the relation between degree of P of x and degree of Q of x?
P of x is greater than Q of x.
Greater than Q.
Greater than or equal to.
P of x is greater or Q of x is greater? Which one is?
P
P
of
of
x
x
is
is
greater.
greater.
Okay. So you are saying the degree of P of x is greater than,
Polynomial.
right? So in this case, so these are some basic relations which you should know. Okay. So now, because of this, can we say that it is same as saying it is strictly less than degree of P of x minus 1? Is this same as saying this? Less than or equal to So degree of R of x is less than or equal to degree of P of x. So it is strictly less than degree of P of x minus 1. Can we say this? So degree of R of x, first of all, can it be equal to degree of P of x?
Yes, ma'am, it can be.
Okay. What about degree of Q of x and R of x? How can you say that degree of R of x is equal to P of x? Is it possible in what situation?
Ma'am, it is possible when the divisor is a constant and px is a polynomial, I guess.
Sorry, how? Can you repeat it?
Ma'am, I am saying when the divisor is a constant
Okay.
and dividend is a polynomial.
Okay. So in that case, what happens to R of x?
Then R of x is equal to P of x. The degree of R of x is equal to P of x. That is dividend.
Degree of R of x is equal to degree of P of x.
Yes, ma'am.
Okay. So first, maybe we'll take some specific cases in that case and we will solve it. So first, let us talk about the minimum degree of R of x. So minimum degree of R of x, first of all, it is only 0. It cannot be degree of P of x minus 1 and degree of Q of x minus 1 or 1. So is that clear? Why is it is 0 and not these things? Is that clear? Because see, degree of P of x, it can be any number, right? Any natural number. It can be 3, 4, 5, 10, 12, anything, right? So the minimum degree cannot be, also similarly for Q of x, it can be any natural number, right? So degree of P of x minus 1 or degree of Q of x minus 1 definitely is not the minimum degree. The minimum degree is 0. Is that clear? These are not the correct options. Is that clear first of all?
Yes, ma'am.
Yeah. Okay. Now,
Can we say degree of P of x and R of x is same?
P
It
of
will
x
be
and R.
same.
No. Maybe we'll do some specific examples.
Ma'am, if in the question it is asked, like if we can go back to the question,
Yes.
if it is asked that what is the maximum degree of R of x, then B and C can be right.
That is the next question. So that
Okay.
is the next part. We are going to see that only. Okay, fine. So now the next question is, okay, so first here the same explanation is given, whatever I have given. So degree of the remainder R of x should be strictly less than the degree of the polynomial Q of x. So this is what I was asking. So here, so degree of R of x, first of all, should be strictly less than degree of Q of x. This, do you agree? So here I wrote it here. So this is actually strictly less than Q of x. Do you agree with this?
Yes, ma'am.
Yes, right? So degree of R of x is strictly less than degree of Q of x. Okay. Now, what is that you see next? When the remainder is constant but not 0, then in that case, the degree of the constant polynomial is 0, right? So when R of x is equal to C, where C is non-zero, then degree of R of x is 0, right? If R of x is 0, then the degree is not defined. Okay. So in that case, the minimum, from the given option, the minimum degree is 0. Okay. Now we are looking at the other part, which is the maximum degree of R of x, right? What are the relations we have seen so far? Degree of R of x is strictly less than degree of Q of x. And what is the relation between degree of Q of x and P of x?
Degree of P of x is greater
Px
than
is greater than or equal to Qx.
So in that case, now whoever told that it is possible that degree of R can be same as degree of P. So I want you to rethink whatever you said. Rethink, is it possible that they can be same? It's never possible.
No, ma'am, it's not possible. The remainder and
Yeah. So degree of R of x is always less than degree of Q of x and degree of P of x.
Ma'am, you are saying degree of R of x cannot be equal to degree of P of x. You are saying that.
Yes.
Ma'am, suppose the dividend is a polynomial and the divisor is a constant, then it is possible, na?
So first of all, this condition should be satisfied, right? Q of x is less than or equal to degree of P of x. Are you considering this or not?
I don't think I'm considered this.
So that is the case we are considering. When we
But
are considering an equation
it
like
can be
this,
equal also, na ma'am. If we are considering this, then quotient, the degree of quotient and degree
see,
of
even if you are considering it equal, here you have a strict inequality, right?
okay.
That's not possible. So always suppose the degree is equal. See, usually for when do we get a reminder? Only when the degree is lesser than q of x. If the degree is same as q of x, you are going to keep on dividing further and reduce it, right? It's never equal, right? Yeah, do you understand? Even here, if you get a equality, here you have a strict inequality. So obviously, degree of r of x can never be equal to degree of q of x or degree of p of x. Is that clear?
Ma'am, in the last slide, it is written that strictly, just in the last slide, it was
Yeah.
written that it was, oh yeah. Just the next one. Ma'am, not the question one, in between the question. Yeah, this one.
Yeah.
Ma'am, what is the meaning of should be strictly less than? What is the meaning of this?
So this is the meaning. So this strictly less than.
Which has no equal sign. You are saying that. Okay.
Yes, yes. Okay. Is that clear?
Yes, sir.
Okay. Fine. All right. So now with this, it is easy to tell the answer. The maximum degree of r of x can be, so it cannot be degree of p of x or q of x. So what about the other one? What is the maximum degree? Degree of p of x. Now from here, you know that degree of q of x minus 1 is less equal to degree of p of x minus 1. Now tell me what should be the answer. What should be the answer?
Degree of q of x minus 1.
Yeah. So the maximum is this, right? So it cannot go beyond this. We have this relation. So degree of r of x is less than or equal to degree of q of x minus 1. So the maximum possible value is this. So this is the maximum possible value. Okay. Is this clear? Yeah.
Yes, ma'am.
Okay, fine.
Ma'am,
Okay.
why option B is not there?
Can I ask some question, doubt?
Yeah, but let me just answer this question. Why it cannot be p of x minus 1? See, we have this relationship that q of x is less than or equal to p of x, right? Degree of p or q of x is less than or equal to degree of p of x. So suppose, for example, this degree can be maybe, let's say this is 10 and this is 12, right? So here in that case, this will be 9 and this will be 11. So what will be the maximum possible value? The maximum is 9 only, right? Because already see, this inequality itself tells that this is the maximum. It cannot go beyond this, right? Already we know that this is less than or equal to this. So we cannot just go beyond this value, right? You understand? So from this inequality itself, already we know that this is the maximum possible value. Do you understand?
Ma'am, in the exam, if they give two
No,
equations,
ma'am.
Yeah.
two functions,
Okay.
so we should only check this condition. So if they've asked for maximum degree of r of x, we will only check it with q of x and not check it with p of x. Is that right?
Yes, that's enough. Checking with the
Okay.
degree of q of x is enough. Yeah. Okay. Yeah. So what was the other question? So someone else was also having a doubt. Okay.
Ma'am, is this material
Yeah, ma'am.
available?
Activity 4.4, question number
No,
1.
no. So doubt clearing session is different. This is different. So if you are having doubts in this particular part, you can ask. But if you are asking something different, so we will discuss that in doubt clearing session. Okay. Questions,
Ma'am,
doubts from
When
this
will be
part,
the
you
doubt
can ask.
reading session will be held?
Sorry.
For week 4, when will be the doubt clearing session held?
It must be there in your schedule. I'm not sure about the schedule. So if you want, I have to check and tell. Maybe I will check
ma'am, it
and
is the TA session which just held 4 to 6. I think it's in the calendar. People who are aware of that, they attended it. They are the TS sessions.
Okay, so you have TA
No,
sessions
I'm
as
not
well as
getting any
instructor
TA
sessions for doubt
session. Can
clearing,
you
I
please
guess.
help me out to convey this message?
What you want to convey?
I'm not getting any TA session, any statics class, any CT class. No, nothing.
Please post it in post an email to support. Definitely you will get a reply. Also maybe put a message in discourse post. So definitely you should be getting a response. Okay, tag the instructors and TAs. Definitely you should get a response quickly. Okay, fine.
Sometime you does not see calendar or calendar in a calendar app. So try to open in a Google or Google in
Okay,
different
please
mode.
have this discussion at the end. Okay,
Ma'am,
continue with
this,
the topic.
ma'am, this, the last question I didn't got it, -1. Can you just like, yeah,
One?
how did you said that the B option is not right, ma'am?
Okay, so let us see what is that we are having. Degree of R of x is less than or equal to degree of Q of x minus 1. Already you know that this degree of R of x, the maximum possible value is this. It cannot go above this value. Yes or no?
Yes, ma'am.
So if it cannot go above this, now degree of P of x minus 1 is above this only, right?
Ma'am, how degree of QX is above, it is less than, na, it is in the sign.
That's
The
what I'm
degree of,
saying. Degree of P of x minus 1 is above. See,
yes,
your,
ma'am.
your value of, let's, so your value of degree of R of x is somewhere here on the real line. So this is your degree of R of x. Okay. And your degree of Q of x minus 1 may be somewhere here. So let's say this is A, B, C. So somewhere here. So, and this is somewhere here. So obviously this A cannot take values beyond B, right? And your C is beyond B. So it cannot definitely take this value, right? Got it?
Ma'am, if degree of Q of x is equal to degree of P of x, then it can take the value of degree of P
See,
of
that
x,
is
right?
one special case. We are talking about the general scenario. You are talking about one specific case. It is possible that they are equal. But in general, what is the case? This is the maximum possible value. Is that fine?
Okay, ma'am.
Okay. All right. So moving on to the next question. Consider this polynomial. Okay. See, this is a question where you can understand several concepts together. So try to listen to this carefully. You can understand, you can learn many different concepts from one single question. Okay, so listen carefully. So you are having this polynomial here. Okay, now we are asked to check the following. How many number of turning points, whether it is increasing or decreasing in a specific interval, whether it is odd or even, whether it is 1 to 1 in a specific interval. So all these questions we are going to see. So the hint given here is draw the graph of P of x. Okay, so to draw the graph of this function, what are the things we need to know? We need to know, first of all, what is the degree of this polynomial? Can you check what is degree of the polynomial?
Ma'am, 9.
Degree is
9, ma'am, 9.
okay. So if degree is 9, now we are looking at the coefficient of the highest degree. So see, first of all, note that this can be rewritten as x plus 10 whole square. Yes or no? This is same as this. Yes or no?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
if this is same, now when you multiply, okay, so when you multiply, only this part I'm talking, without this constant, when you multiply, you will get x power 9. Okay, x power 9 without any negative sign. But now when you multiply this negative sign, so what is the coefficient of x power 9? Is it positive or negative?
Negative, ma'am.
Negative.
Negative. Okay, so the coefficient of the highest polynomial is x power 9 and that is negative. Okay, if that is negative, this helps us to determine the end behavior. What is mean by end behavior? It means what happens at the ends. Like what happens as x goes to infinity and x goes to minus infinity. Okay, now as x goes to infinity, since this coefficient x power 9 is negative, what happens as x goes to infinity when you have a negative value?
It goes to minus
P of
infinity.
Minus
x is
infinity.
tends to
Yes,
minus infinity.
yes, this goes to minus infinity. Similarly, as x goes to minus infinity, your p of x goes to
Infinity.
infinity. Okay, so this is the end behavior. Okay, next we have to look at what are the places where it crosses the x-axis. Okay, so it means we are looking at the roots. So what are the roots of this polynomial?
Goes
First
to
one is
8.
10.
Minus 10,
Minus 10.
X equal to
8.
8.
Mm,
8,
Let's go in an
6.
order, like maybe in a increasing order if we go after minus 10.
9. X equal to minus 9
Yeah.
minus
plus 8.
Uh,
2,
there
No,
is
ma'am.
a
2,
zero here.
0, 0,
0, 0.
Yeah.
Plus
2,
2,
4, 6.
4, 6.
4, 6, and 8.
You see, these are the roots. Okay. But there is a difference between the roots, other roots, and 10 and 0. What is that? These roots are occurring
Negative.
how many times?
Multiplicity
2
is 2.
times.
Twice, right? So these are occurring
Twice.
twice. So in these places, you have turning points. Okay, so in these places, you have turning points. So with this information, we will try to roughly draw the graph. We cannot draw a very correct graph, but we
Then one thing, if the multiplicity of the roots are 2, then there has to be a turning point. Is it a rule?
yes. See, they are like end of the vertex in a
Hmm.
quadratic equation, right? You can imagine like
Okay.
that.
Okay. So whenever the multiplicity of the roots are 2, it has to be a turning point.
Exactly. Okay, so here we will try to draw the graph. Okay, roughly, not very precisely, roughly to get an idea. Okay, we'll try this. So -1, -2, -3, -4, -5, -6, -7. Okay, here I'm not able to draw, so maybe, sorry. Better I will.
Ma'am, I want to know how minus 10 and 0 have turning points and other even numbers don't have the turning point.
Okay, so in that case, see, for that you have to specifically try drawing some graphs and understand it. Maybe we'll do after completing this problem. Okay. So first let's complete this. I want more space here. That's why I had to remove and draw again. Okay. And here we need till 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now, okay, let's try to draw. So here, what are the end behavior? Towards minus infinity, the values are going up, right? And then at minus 10, it should touch the x-axis, right? So it means, should we come from above to minus 10 or from below to minus 10? The graph,
above.
yeah, because it's increasing,
Yeah,
right?
ma'am.
So here, when you are going towards minus infinity, the values are going up. So here, you have a graph like this, and then it will touch the graph at minus 10. Okay. And then here, you have a turning point. You have a turning point at minus 10. So it means it will go up like this. And then again, it should touch minus 9, right? And
Yes,
then
ma'am.
it will come something like this, and here something will happen. We don't know exactly how it looks. And then what happens again? It's going to meet at 0. The graph is going to meet at 0. Okay. And then again at 0, what happens? It's going to have another turning point. Okay, so it's going to be like this. And then again at 2, it's going to cross like this. And then again at 4, it touches the x-axis. And then again it touches at 6. And again at 8. And after 8, what happens as x goes to infinity? The values are going towards minus infinity. So it should go down. Yeah. So after this point, it should go down. So this is the rough idea. Okay. So in general, what do you know about the number of turning points and the degree of polynomial?
Ma'am, the number of turning point is 1 minus the degree. The
So-
maximum number of turning point is degree minus
Ma'am,
1.
8.
Yeah. Yeah. So maximum number of turning points of P of X is
Eight.
P of
Minus
P
1.
of X minus 1. Right? So in that case, it should be 8. It cannot be 9. 9 is not possible. Right? So this is incorrect. So from here, we can check how many turning points it will have. So here, for example, let's put the numbers. So this is the first turning point, and somewhere here we will have another turning point, and somewhere below here you will have another turning point. Here you will have another turning point, and here you have another turning point. And then
And there will be the 0 and 2, between the 0 and 2 also.
oh yes, correct. I missed it. So here you have another turning point, here, here, and here. Okay, so you can have turning points only in these places. Okay, so you cannot have more turning points. So now let's look at the actual graph and see how far we were able to make it. So this is the actual graph. Okay, so you see at minus 10, it's coming up and going down like this. Okay, and then again it's coming down, 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 going up. All right, fine. Okay.
My question is that how we know that only minus 10 and 0 has turning points, and
Okay. So
it
now,
doesn't turn into 4, 6, 8.
yes. Now we have to look at what is the definition of a turning point. What's the definition of a turning point?
Even on even numbers,
Do you already
it
know the
shows the
concept of derivatives?
The
for even
definition
numbers,
of turning point is that the graph changes its behavior from positive to negative.
The slope
Or
will change.
negative to positive.
Direction. Yeah, you can either say it in the
Ma'am,
way that the
increase to
slope
decrease.
direction will change, or
Increase.
it changes from increasing to decreasing, or you can say the derivative is 0. Yes or no? Yeah.
Yes, ma'am.
So in the perspective of derivative, you can understand. Suppose you say, for example, if you are having x squared, what happens to the derivative, even x plus 10 whole square? So when you are taking the derivative, you will have 2 times of x plus 10. And the derivative, if it is equated to 0, you know that you have a root here. So it means this is a turning point. You understand?
yeah.
Okay. So that's the reason here. If you
Ma'am,
understand.
can you repeat that?
Okay, so see, the derivative should be 0 at the turning point, right? So for example, if you take this one, what is the derivative? It is 2 times of x plus 10. And when you equate it to 0, what is the root you are getting? Minus 10. So whenever you are having this even degrees, so you will get the roots for the derivative. That's why you are having turning points.
Ma'am, how is it the derivative is 2 into x in x plus 10? Yes, ma'am.
So that part will come. It will not be exactly equal. Only if you are, so for example, I'm saying, suppose for example, if you are considering only this function, what is the derivative?
It's 2 times x plus
2
10.
into n minus 1.
Exactly. That is why if it is 2 times of x plus 10, now what is that you will have when you equate it to 0? X is equal to minus 10 is the root. Yeah?
Yes, ma'am.
Yeah. So now it means that is a turning point. Okay?
Ma'am, can we say this is a quadratic function and the roots are 10 and vertex is at 10?
It's not a quadratic function. Quadratic means the degree of the polynomial is 2, right? This is a polynomial of higher degree. No.
If you consider only the x minus 10 whole square.
Yeah, so if you are considering only this is of course a quadratic equation, but here we are looking at a bigger function where only this is a part of the function. Okay, so turning points occurs at places where you have degree 2 here. Okay.
Ma'am, just one doubt, ma'am, one doubt I have. Suppose there minus x minus 10, the degree is not 2, it is 3. Yes, ma'am, here.
Yeah.
The power become 3. Minus x minus 10 to the power 3, suppose. So
Mhm.
then there will be no turning point na, at that.
We will not know whether it has a turning point or, for example, yes, for x cube, we will not have a turning point, right? Yes, so if for some cubic polynomials, we may not have a turning point at all. Yes, it's possible.
For all, or is it like for all of the
No, it's possible. See, for cubic polynomials are very strange polynomials. It may have turning points, it may not have turning points. The numbers will vary. So
okay.
that's why we are saying the maximum is degree of p of x minus 1. It's not exactly equal to. The maximum number is 8. It can be less than that also.
No, ma'am, I am particularly asking this case minus x minus 10. Suppose this power has become even, suppose, for example, not 2, like 4 or 6, any even. So the multiplicity will be even only. So if there is an even power, there will be a turning point. My doubt is that. We are sure that suppose minus x minus 10 to the power 4 or to the power 6 or to the power 8. So if there is an even power or even multiplicity, so there will be a turning point for sure, na?
Yes, yes, yes.
But if there is an odd power, then we are not sure. Then then the multiplicity of the root is odd, so we are not sure if it is a turning point or not.
In that case also it may have a turning point. Yes, may or may not.
But if the power is even, then turning point is sure.
Yes.
But for the odd, we are not sure.
Uh, it I guess
For
it
odd, it will
will have
be
a
a
turning point.
intersection. It will be a point of intersection, not a turning
Then,
point.
ma'am, for odd, it cross the line, right?
For all the odd
Like for
numbers,
x
it will
cube.
cross the x-axis, ma'am.
It
For
will
even,
cross
then it
the.
For say
will
it is x
Yes,
cube
that's why
x
I'm
to the
saying it
power
may
5.
or may not have. It depends on the particular question, particular example we are considering. Okay, so only this will guarantee that there is a turning point. In other cases, it does not guarantee a turning point. Okay.
Okay, ma'am. So whenever there is a power, for example, minus x minus 10 to the power 2, so the multiplicity is also 2 here, ma'am.
Here, the multiplicity, what do you mean by multiplicity?
The roots are repeating.
Yes, yes, the roots are repeating twice.
Yes.
Okay.
So multiplicity is that only, na? How many times the roots repeat?
Yes, yes.
Okay.
Okay. All right, fine. So the next part, yes, we are comparing the graphs, what we have done and what is actually there. Is it making sense? So the first part, yes, we have done it correctly in this place, right? And then here, this is at -9. Yes, it's touching the x-axis and then it's going down. All right. And then again at 0, it is touching the x-axis and then again it's coming down and then coming up and touching 2. And then again it's touching at 4, 6 and then going up on it. So exactly how far it goes up and down, that we cannot say it unless we are really like calculating everything correctly. But this much, if we are able to draw, we will be able to answer the questions given here. Okay, we don't have to precisely draw this much. Sorry, precisely draw this much. Okay, so up to this,
Ma'am, this material mathematics week 4, this is available on our
yes, it is there in your portal.
portal or in our discussion forum?
I'm not sure. So usually all these solve with us slides are already available to you. I don't know exactly where, but it should be available. Please
Okay.
discuss it with your friends.
Yes,
Okay, so
sir.
let's continue here. Okay, so
If
now,
there any discussion forum, please add me there, if it is possible.
sorry, I am.
Actually, discussion forum, you only have to see it. You got the email, so in the discussion forum, there is a message kind of a thing. You go in the course, you click on that and log in.
Okay, okay. Please discuss it in maybe after the session. Okay. Okay, fine. So the next part is here. We have first finished the first part, and the next part is p of x is increasing function when x is in 6 to 8. What is mean by increasing? Increasing means for any value between this. So you have, so for take any two values, x1 and x2 between this, okay? So x1, x2 are between 6 and 8, okay? So then p of x1 should be strictly less than p of x2. So this is the definition of increasing, right? So now here, between 6
Ma'am,
and 8,
one question.
yes.
The 6 and 8, we will consider it as closed interval?
No, because here it is open bracket, it is open interval only.
Ma'am, this that you
Only
have
when you
written,
have square brackets, it is closed interval. Yeah.
ma'am, what you have written px1 less than px2, that is for strictly increasing, na? Here it is increasing, so there has to be an equal sign also, na?
Okay, let's take equal to. But still you can clearly see that here it is not possible. Why it is not possible? See, the function is going down and then going up. So obviously for values you take here and here, what happens? The value is going down, right?
Ma'am, it's between 6 to 8. You are taking from 4 to 6.
Oh, sorry. So either way, yeah. So 6 to 8. So if you are taking this part, okay, maybe you can even look at this part here. So this is, maybe I'll use a darker color. Yeah. So this is 8 and this is 6. Okay. So you see, this is some point between 6 and 8, right? So let's call it maybe some A, right? So from 6 to A, the function is increasing. And from A to 8, the function is decreasing. So between 6 to 8, overall, we cannot say whether the function is increasing or decreasing, right? So here, this is incorrect. Why is this incorrect? Is that clear? Yeah, P
What
of
we can
X.
say, ma'am, what we can say between 6 to 8, if there is a correct option,
The
what could be
the function is neither increasing nor decreasing.
okay.
Okay, fine.
Ma'am, I have one doubt. What is the difference between strictly increasing and increasing? A little bit doubt I have on
Okay,
that.
so for example, so suppose you have a function like this, for example. Okay, so this is increasing and this is strictly increasing. You understand? So in some places they can be equal and then it can increase and then again it can be equal and then increase. This is increasing function. This is strictly increasing function. At no 2 points they are equal. They
For
will just
example, x square, x cube, x to the power 5, they are strictly increasing kind of functions.
No. You have to be careful about the domain of whatever you are saying. You have to be very careful. They are not increasing functions.
Okay.
Yeah.
So when slope is constant, we say it to be strictly increasing.
Slope is, here you are saying the slope is constant in the sense that for any point, yes, the slope is a constant. Yes, in that case, it is strictly increasing. Here, the slope is either 0 and then positive 0 and then positive. Yes.
Either the slope is constant or the slope is also increasing with the value of x. Then we can say that it's a strictly increasing now. For example, the slope is also increasing. Then also we can say that now.
We say there is no turning point, then it is strictly increasing, right?
If there is no turning point, see here also there is no turning point. It's increasing only. It cannot say that it is strictly increasing.
For example, ma'am, the graph of x square, if we take the domain from 0 to infinity. Yeah, ma'am, that is also strictly increasing now.
Yes, this is strictly increasing.
Okay,
Yes.
ma'am.
Okay. All right. So the slope is actually increasing only here. Okay. Need not be the same at all the points. So only when you are taking a linear function that applies. Okay. Fine. So what is an odd function? How many of you can tell the definition of an odd function? What is an odd function?
F of
f
x
of
is equal
minus
to
x is
minus f
equal
of
to
x.
minus f of x.
Okay. So what is the geometrical significance of an odd function? So this is the definition. What is the geometrical significance of an odd function?
Not symmetric about the axis.
It is symmetric about?
Not symmetric.
It is symmetric about something. What is that? Can you say?
Y equal to x line.
No, ma'am, it's not symmetric about the axis. Y-axis.
The significance is
Odd
much more
function
than
is
that.
symmetric.
See,
Symmetric
even
about
function
origin.
is symmetric about y-axis, but here this is symmetric about something. What is that? Can you say?
Origin.
Yes, exactly. It is symmetric about the origin. Okay, so for example, if you are taking p of x is equal to x cube, is it an odd function?
Yes.
Okay, so x cube is an odd function. If you are drawing the graph of x cube, so you can see that there is a symmetry about the origin. You can try drawing the graph of x cube or x or any odd degree polynomials. You see what's happening. Okay, you have some type of symmetry you can definitely observe. Okay, so what is mean by symmetry of a function in general? So symmetry means what? Just the meaning symmetry. What is the meaning of symmetry?
Equal part.
Okay, some equality or similarity you can observe. Okay, so that is what you are saying. So for I'm not very good at drawing. That's why I'm thinking, okay, so x cube, maybe I'll try to draw something like this, but it should be something like this. Okay,
Yes, ma'am.
so you see some kind of symmetry is there. Okay, similarly, if you take f of x is equal to x, so that also will give you some, you can observe some symmetry. Okay, and whenever you are considering polynomials, in fact, the roots are symmetric. It means, so you can see that about the origin on either side, the roots will also be symmetrically arranged. Okay, but here obviously there is no symmetry about the origin. You see that the roots are at random places, there is no symmetry and all. Okay, so this is definitely not an odd function. So that you can see directly from the graph, or if you have a confusion, just go back, apply the definition and do that. It's just a long way. We don't really need that once
Well,
you
you are saying the geometrical significance of odd function is that it is symmetrical about the origin, and the roots
origin.
are also symmetrical. I mean, equally distance as
Yes,
compared with
yes,
origin.
yes. Okay, all right. Okay. Now, P of the next option is P of x is 1 to 1 when x is in here. It's x to infinity.
Ma'am, can you explain this px1 is greater than equals to px2?
This one?
Yes, ma'am.
Okay, so this is the definition of what is meant by an increasing function. So increasing function means you take, so suppose you take any interval, okay, you take any interval and you take any 2 points, x1 less than x2. Okay, so here x1 less than x2 is important. You take 2 points x1, x2. Okay, if p is a increasing function, then p of x1 should also be less than or equal to p of x2. That's the definition of increasing function. All right. Okay, this is the definition.
Ma'am, what is the definition? Can you repeat once again?
If x1 is less than x2, okay, for any x1, x2 within the interval. Okay, so let's take x1, x2 in some interval a comma b, and x1 is less than x2, and p of x1 is less equal to p of x2, then we say p is increasing in the interval a comma b. Okay, fine. All right. So the next thing is p is 1 to 1 when x is
Yes,
n.
ma'am.
Yes.
Ma'am, can you please re-explain B part?
B part. This one.
Yes, ma'am. Yes, ma'am.
See here, this is the definition first of all we have said, right? Now consider this interval 6 to 8. Now take some point here. So let's call this point as our x1. Okay. So the corresponding point to this is x1, or maybe even this a is your x1, let's say. Okay. So let's take this point as your x1. And somewhere here is your x2. Obviously, x1 is less than x2, right? And it is inside the interval 6, 8. Now, what is P of relation between P of x1 and P of x2? Look at the y values. So, this is your P of x1. And here, this is your P of x2. So, which is higher, P of x1 or P of x2?
P of x1.
So can it be increasing?
No, ma'am.
Clear?
So, ma'am, in the B option, you are saying Px1 less than or equal to Px2. That is increasing. But
Yes.
if we remove the sign of equal to, then it become
Strictly increasing.
strictly increasing. So this equal to sign determines strictly increasing or just increasing.
Exactly. Exactly. Okay.
Ma'am, in the C option,
Hmm.
p of x is an odd function.
Hmm.
Can we put a negative value in the function and try whether the result is minus p of x? Can we try
Yes,
that
yes,
way?
yes, definitely we can do that. That's what I said. Either you look at the graph and understand from the geometrical view, or you just look at the function, put p of minus x and see whether you are getting minus p of x again. Definitely you can do that.
Okay, ma'am.
Okay. Okay. So here you see the degree of the polynomial. What is the degree of the polynomial? Very easy to see from the definition also. Put p of minus x and then put minus x everywhere. So how many minus you will get? 1, 2, 3, 4 and 5. So that you have a minus outside. So it will get cancelled, right? So p of minus x. Are they same or different? Okay,
They're
try it
different.
out. Okay, try this definition. Sorry, what?
The minus cancels out.
But then what happens to the to the components of this polynomial? Okay, so let's maybe if you want to
Ma'am,
understand.
can you repeat this question?
Okay, so let me write it maybe for you. So you want to understand what is p of minus x. Okay, so p of minus p of x is simply 1 by this number, right? And this factor. Just you have to remove this negative sign for minus p of x. But here, what happens to this p of minus x? So for p of minus x, you have 1 by 1 lakh, and then here instead of minus x, so x you have this, you can write it as actually x minus x plus 10 whole square, and then this is minus x minus 8, and then this is minus x minus 6 and minus x
How is it minus x plus 10 square?
because I'm replacing x with minus x. Here p of x means I have to replace x with minus x. Okay. So now obviously the polynomial changes, or does it remain the same?
Changes.
Changes.
It changes.
Ma'am,
Yeah,
it become x minus 10, na? X minus 10 whole square.
Yeah,
Why
so
did you?
so you are saying that this will become x minus 10 the whole square. So you see obviously it's changing, right? So this becomes x plus 8. So let's take the minus commonly. So here you have a minus, and then here you have a minus, and here you have a minus.
My point is that in the first line, when you wrote minus 1 upon.
So 1 minute. So let me just complete this. So here in all these places, we are taking out the negative sign, right? So now here, if you are taking out all this negative sign, minus into minus, minus into minus, here everything cancels, and this is what will be remaining. And you see that this is not equal to minus p of x.
Ma'am, what I'm saying is when you wrote this function p, when you just replace x by minus x on the first line, yes, ma'am, here. How come you said it minus x plus 10 ka whole square? It should be when you put x is equal to minus x, it would be x minus 10, na, ma'am?
See, I have already replaced minus x minus 10 with x plus 10 whole square, right?
Ma'am, but
Either you consider this or that,
ma'am.
does not make sense. It does not make a difference.
Okay.
Right?
But why did you write minus x plus 10? Because just before that you wrote x plus 10, na?
Yes, x plus 10, and
Yeah.
here x I'm replacing with minus x.
Okay, got it, ma'am, got it.
Yeah, all right. Okay, so p of x is a one-to-one function. So for one-to-one, what is the test you have? Vertical line or horizontal line? What's the answer?
Horizontal.
Horizontal line test, right? So for to check whether a function is one-to-one, what does the horizontal line test say?
We have to inject horizontal line on that domain of the graph.
Yes, in that domain, if you put a
Not
horizontal
intersect.
line, then it should not intersect the graph at more than one point. Okay, that is horizontal line test. So now after 8, we know that the function is decreasing, right? And then there is no turning point after this point, right? So if there is no turning point, then it means it's just going to keep on going down only. So you can see that if you put any straight line here, so after 8 only you have to put, remember that also. So it's after 8, okay? So it should not come here. Then maybe at some point it will intersect here and all. So only from 8 you have to check, okay? So you have to check from 8, you put a horizontal line, you can extend it till infinity. You can definitely see that it will not cross the horizontal line anywhere else, but just at one point, okay? And hence in this part, it is one-to-one. Is this clear why it is one-to-one?
Yes, ma'am, it is clear.
Okay.
Ma'am, just one thing, just above when you were finding it, yeah, here, just above that, where you put a p to the power p minus x, you put it. Yeah,
Yeah.
this was regarding. What did you explain from this, ma'am?
So P of minus x is not equal to minus P of x.
That
And
means it's not a
is not
odd
odd.
function. Okay.
Okay. And then the next question here is,
Ma'am, I have a query. As you said, px is not an odd function in the last question. So x to the power 9 is an odd function.
sorry, what? Yes, P is not odd. Yes, what's your doubt? X to the
And
power?
point C, x to the power 9 is is an odd function, right? The degree is
X,
odd.
degree is odd,
Not
does not
related to the
no,
degree.
no. That is not related to the degree. Okay.
Ma'am,
Ma'am,
can we
can you
say that?
explain this P point?
Okay, what is your doubt here? See, this
Ma'am,
is
how
the
to find
definition.
independent?
See, this is the definition, and you see that it is not satisfying the definition, so it is not odd. So I have explained this part. What is your specific doubt? Please ask me. It's not satisfying the definition. This is the definition of odd function. It's not satisfying the definition. P of minus x is not equal to minus P of x.
Okay, ma'am. Okay.
Ma'am,
Okay.
this function is not odd. That means, so does it mean that it is even?
No,
Then,
no.
so a function cannot be even also and odd also.
That
Okay.
is, yes, definitely there. Okay, so a function neither,
Okay,
it can be neither odd nor even.
okay, ma'am, we can go to the next question. Thank you.
Ma'am, I have one doubt. Ma'am, when we check increasing or decreasing, like we have to differentiate, right? But in this case, how can we differentiate such a big function? Like for the option B, how did you check that?
I showed with the graph, right? Did you listen to that part or not? When
Oh
I showed,
yes, ma'am. Yes, ma'am. Like the graph we drew from that, from
yeah.
there you we concluded, right?
Okay. Okay.
Ma'am, one last doubt, ma'am.
Yes.
Ma'am, in the one-to-one function, does it mean for each value of x after 8, there should be only one y values?
Yes, exactly. It is mapped to one value. It cannot map to more than one value.
Okay.
Okay, so it
Okay, ma'am.
means what? So if you take two distinct numbers, it will be mapping to different numbers. It cannot map to the same number.
Okay, thanks.
Fine. So next question here is that given that m, n and p are the roots of the polynomial and the sum of the root is 0, then find the value of m cube plus n cube plus p cube. Okay, so now this is the question given to you. Okay, so if these are, so how many roots first of all are there for a cubic polynomial?
Maximum 3.
3.
Only 3, exactly 3 roots only, right? And they are given to be m, n and p, right? Okay, so if m, n and p are the roots, then you know that you have to first of all equate it to 0 to get the roots, right? So if you see that this is, maybe if you are calling this as f of x, then what does it mean that m and p are roots? When you substitute m and p in place of this, you will get 0, right? So that is the first thing, right? So you know that, okay, so f of m, f of n, f of p are 0. So their sum is also 0. So here we are going to do some shortcut. Instead of calculating what are m, n and p, we are going to do some shortcut. Okay. So how are we going to do? Because you see m cube, n cube, p cube are there within, this is what we need to find. And they are here within this expression. So we are trying to see what we can do with this expression. We know that this sum is 0. Okay, so let's write the sum together. Okay, and this is the part we need. So this is the part we need, right? And so you see that what we can do with this part we are going to see. Now the given information says that the sum of the root is 0. What if the sum of the root is 0? What do we know? M plus n plus p is equal to 0, right? So this means this part becomes 0. So you have m cube plus n cube plus p cube is equal to 30. Okay, so here you have to see, you have to make use of all the given information. You may think that how do you know that we can use the shortcut? Why can't we simply calculate the roots and find it? Yes, you can calculate the roots and find the sum. You are going to get the same answer. But make use of the given information completely so that you don't have to waste too much time in calculating the roots. You can straight away use some tricks and find the answer.
Ma'am, I have a question, ma'am.
Yes.
Ma'am, there is a formula, no, ma'am. For alpha cube plus beta cube plus gamma cube equal to d by a s3 for cubic polynomial.
Yes, that's what I'm saying. You can use the root, find the roots of the cubic polynomial, find the answer. That is also there. But you
If
don't
we use that,
answer.
it
You
gives
will
us
get the
10
same
value,
answer.
ma'am.
Yes,
It
definitely you will
gives
get the same answer.
in this case, d value equal to 10, ma'am.
Yes.
10 by a means 10 by 1. We use m cube plus n cube plus p cube equal to 10 only, ma'am. But in this, we got answer as 30.
No. What is m, n, and p? So just from 10, how can you say m cube plus n cube plus p cube?
Alpha, beta, gamma, ma'am. We assume that m and p are alpha, beta, gamma.
Okay.
For cubic polynomial, condition is there, no, ma'am.
What
Alpha cube
condition?
plus beta cube plus gamma cube equal to minus d by a.
So that is the sum, but it is the sum of cube of the roots. That is the sum of the roots, na? Here it's the cube of the roots, cube roots of the sum.
Cube
See, you
roots,
are talking
bro.
about the
Yes,
coefficient of x squared. The coefficient of x squared is the sum of the root.
yes, ma'am.
Yes.
But S2, S3 also there, no, ma'am.
Yeah. So you are talking about the coefficient of x and the constant.
Yes, ma'am. Constant.
Okay. So what is the relationship you are talking?
I think it's alpha cube plus beta cube plus gamma cube equal to minus d by a.
I guess you are misinterpreting some formula, I guess. Please go and check the formula once.
Okay.
Okay. There must be some error.
Ma'am, alpha beta gamma is equal to minus d by
It will be 0 only because that is minus
the
b
formula, I
by
think
a. Ma'am, the person who asked it, the sum of the roots of a cubic is minus b by a, and minus b is the coefficient of x square, so that is 0. So it has to be 0 only.
Okay.
Ma'am, the sum of the roots of a cubic polynomial is minus b by a, and b is the coefficient of x square, so that is 0. So it has to be 0 only.
Okay, fine. All right. Okay, moving to the next question here. Okay. So here,
Ma'am, I have a doubt in the last question.
yes,
How we get 30 in the line?
we are adding all this.
In the fifth line, yeah, how we get minus 30 instead of minus 10?
Minus 10, minus 10, minus 10 added up minus 30. We are adding them.
Ma'am,
We are adding all this.
Okay, ma'am.
we can use
Sorry, your voice is not clear.
method also for finding the roots.
Sorry, what are you asking? It's not clear.
Can I use synthetic division method, ma'am?
There is too much disturbance in your voice. So what are you asking? Can you just put a message? Maybe I'm not able to really understand what you're saying. There is disturbance. Okay. Yes, see, as I told you, you do any method. If you are using the correct formula, you will get the same answer for any method. Use synthetic division, find the roots. That's completely up to you. Okay. All right. So moving to the next question. The Ministry of Road Transport and Highways Transport want to connect three aspirational districts with two roads R1 and R2. Okay. So there are three districts where you are connecting them with two roads. Okay. Now, two roads are connected if they are intersecting, right? Now, the shape of the roads R1 and R2 follows polynomial curves f of x and g of x. Okay. So now this is your f of x and this is your g of x. So what will be the x coordinate of the third aspirational district if the first two are at the x-intercept of f of x and g of x? Okay. So how do you, so the question is that you are already given two functions and you know that the first two cities are at the x-intercept of f of x and g of x. Okay. And they are asking about the third aspirational district. So definitely the third aspirational district should be there, which is there connecting both R1 and R2, which is there lying on both R1 and R2, right? So it means that, so first of all, what are the common points for f of x and g of x? Where are they connected? That's what we have to see. Okay. So two roads are connected when f of x is equal to g of x, right? So this is your f and this is your g, right? So now we are going to equate them. When you are equating them, what happens? So suppose let us say your t is equal to x minus 11 into x minus 13, right? So what is your LHS? LHS is t square. Am I correct? And what is RHS? What is RHS?
It's
X is
T. It's T,
Minus
ma'am.
t.
Is minus t, right? So it's given t square is equal to minus t. So that is t square plus t is equal to 0. So t into t plus 1 is equal to 0, right? So you equate t equal to 0, t plus 1 equal to 0.
Ma'am, how LHS came t square and RHS minus t?
Because I am
Yes,
taking t to be x minus 11
Okay.
and x minus 13. Okay?
Okay.
Fine. Now, if t is equal to 0, what does that mean? T equal to 0 means x is equal to 11 or 13.
13.
So these are the two roots. Okay. What is the other root? For the other root, you have to solve this. T plus 1 equal to 0. That is x minus 11 into x minus 13 plus 1 equal to 0. You have to equate it to 0. So if you equate it to 0, then this is what you will get. Okay, so in fact, you will get x minus 12 the whole square. Maybe you can do that. So either you follow this method or this method. Any method is fine. So x minus 11 into x minus 13 plus 1 equal to 0. So what is this? Can you calculate and tell me? X square. Yeah. Calculate. What's the coefficient of x?
Minus
Minus
22x.
24x, right?
24.
Yes.
And then what is the constant term? Calculate and tell me.
143.
43. 143.
144, right?
Yes, ma'am.
So which is nothing
140.
but x minus 12 whole square. right? So this is the other root. The other root is x is equal to 12. So what are the roots? X is equal to 11, 13 and 12.
Either we can do it by
We
by
can
your method or
use
by the book
use
method also.
use the long division method.
You can use either this method or any of your own method. Finally, if your technique is correct, the answer should be the same. Okay.
Ma'am,
Okay. So now we have, these are the three roots. Okay. Now the given information is that the first two districts are at the x-intercepts of f of x and g of x. So what are the x-intercepts?
The roots of f of x and g of x.
So what are the roots of f of x and g of x?
F of x is 11 and 13. G of x is 11 and 13.
Okay. So
Same.
you see that. So from this given information, the first two are at the x-intercept of f of x and g of x. X equal to 11, x equal to 13. So these are the points where first two cities lie. Correct? Okay. So now we are looking at the third point. So what should be the third point?
It should be 12.
It should be
The
12.
remaining.
Okay. So certainly x is equal to 12 is the x coordinate of the third aspirational district. Clear?
So
Okay.
in the question, it is saying that whenever these two graphs will intersect, at
Yes.
that point there will be the aspiration city, na?
Yes. Yes.
Okay.
Okay. Fine. So I hope this problem is quite straightforward and clear. So moving forward, the next question, polynomial fit for the data given in the table recorded by a student is this. Okay. So this is the polynomial and here are some observed values. Find the value of n so that SSE, sum squared error, will be minimum. Okay. So how do you calculate the sum squared error?
SSC equals to ui plus minus xi plus the function fx and the summation from 0 to the given value like minus 3 or 0.
Exactly. Okay. So you take x, y, and then y minus the predicted value whole square, right? The actual y value minus predicted value, the whole square. And then for some square error, you add all these differences, right? Like this. So x, y minus this approximate value square, right? Like this you find, and then you find out the sum of all these values. Sum squared error is the sum of all these squared errors, which is 4 times of minus 2 minus n whole square. So when you expand, you get a quadratic equation. What is this? This is a quadratic equation. So if you get a quadratic equation, how do you find the minimum value of a quadratic equation? So if you have ax square plus bx plus c, what is the minimum value of the quadratic equation?
X is equal to 0.
Minus b by 2a.
Minimum
Minus b
is
by
at the vertex, which is minus b by 2a.
2.
Right? So you calculate, so this is your b is 16 and your a is 4. So minus b by 2a gives you minus 2. So n equal to minus 2 is your minimum value of the sum squared error. Is it fine? Yeah, again, this is very straightforward. You are calculating the sum square error using this formula, and then you are seeing that the sum square error is a function of n, where the function is a quadratic equation. And since it is a quadratic equation, you know that the minimum value can be computed using this formula. You apply the formula, get the answer. Is this clear? Yeah. Okay. So any doubts in
No,
these?
ma'am. Please express one line only. This -2 -3 square plus 3 square, please.
This one you want to understand this part?
Yes, yes.
Okay, okay. So here, what is the formula? So this is yi minus f of xi the whole square. Okay, so each of this value, so this is yi minus f of xi the whole square. What is yi? So this is your y1, this is x1. Okay, so here what are you computing? y1 minus f of x1. This is what you are computing first. Okay, so what is f of x given to you? F of x is given as 3x cube plus 3x squared plus n. X cube plus 3x square plus n. Okay, so now let's substitute that here. So y1, this is your y1, and then instead of x, so x1 is minus 3. So x is, instead of x you put minus 3, instead of x here again you put minus 3, and then you have n. So when you simplify this, you are getting minus 2, and then here you see 3 cube. What is 3 cube? Minus 3 cube minus 27, and here plus 3 cube you are having, and so they
27.
cancel out, and so you simply get here n. So minus 2 minus n square, minus n the whole square, minus 2 minus n the whole square you have got. Same way you have to calculate for each of this. So in the next part, this is your x2, this is your y2, right? So again you are going to calculate what is your f of x2. What is your f of x2? Again you will get, you have to apply. So for f of minus 2 cube plus 3 times of minus 2 square plus n. So what is that? So you will get here minus 8, and then here what is this value? 3 times of 4, so 12 plus n. So here you have 4 plus n, and then here you have a minus 2. Sorry, here you have a 2. So 2 minus 4 minus n is minus 2 minus n. Got it? Yeah. So here
Ma'am.
2 minus n whole square. So that is minus 2 minus n whole square. Same way you have to calculate in every term. This is x3, y3. This is x4, y4. Is this
Ma'am,
clear?
one question.
Yes.
If you see the terms, all the y minus f of x is minus 2 minus n, right? So if we equate that to 0, we will get n is equal to minus 2.
But
So do
why
we
did
need
you
to,
equate it to 0?
because all of them are the same. If they were different, then I can go with the equation. To minimize it, if I put it
Okay.
equal to 0, I will get n is equal to minus 2.
Yes, yes.
So I
That is
don't need to make the
yes,
quadratic equation,
yes, yes, yes.
provided that all of them are of equal, like there's no variation in the
That's a very
numbers.
good observation. If all of them are equal, we can equate one of them to equal. You are we can equate one of them to 0, na? You are saying that.
Yes,
Yes,
yes.
inside
Yeah,
the square.
Yeah,
yeah,
very
that is.
good. Yeah, that is correct. Okay, so any other questions or queries from the topics we have covered today? See, I recommend you to try drawing the graph. So we have an understanding of how these
Ma'am,
graphs,
there is one doubt I
just to
have.
have a visualization, try it as a homework. Try it as a homework to visualize these graphs and the intersecting points. Yes, what's the question?
Ma'am, you said if it is an odd function,
Mm.
it is symmetrical about the origin. Yeah, ma'am.
Mm-hmm. Yes.
And if it is an even function, what is the geometrical significance you said?
For even function, it, see, what about x square? You see, whenever you have some doubts, you have to try it out with some examples. You will understand it very easily. X squared, is it a even function?
Yes, ma'am.
Yes, right? Because f of x is equal, f of minus x is equal to f of x. This is an even function, right? X squared is an even function. How does the graph of an even function look? It is symmetric about?
Y-axis, you are saying.
Yes, it is
So every
symmetric.
even function is symmetrical about y-axis. For example, we can take the graph of cos theta also. That is also symmetrical about the y-axis.
Exactly, exactly.
So every even function is symmetrical about the y-axis.
Yes. Okay. Good.
Can you show the question of the question we are seeing the homework?
Okay.
Visualize.
Okay, so it is this one. Try to visualize the graphs of these functions.
Okay, ma'am. Thank
Okay.
Ma'am,
Yes.
how to find end behavior of polynomial?
How to find
End behavior.
end behavior. So for end
Yes,
behavior,
ma'am.
you have to look at the degree of the highest degree of the highest term, the coefficient of that, whether the term is positive or negative. For example, what is the highest degree term for f of x? X bar
4.
4, right? And what's the coefficient of it? Is it positive or negative?
Positive.
Positive.
It's positive. So it means as x increases, so as x goes to infinity, the value will also go increase. And as x goes to minus infinity, the values will decrease. But for g of x, what is the highest degree term? X square. And what's the coefficient of x square?
-1.
-1. So that it's negative. So that now the end behavior will be reversed. So as x goes to infinity, g of x will go to negative side. Similarly for the other way around. Okay, you understand how to understand the end behavior?
Yes, ma'am. Thank you.
Okay. All right. So I hope today's
There is
session.
one doubt, ma'am, in the second question, in the second or third question, what you were solving just before that, yeah.
Here? Where? Which question? This one?
Just before that, just before that, before this one. Yeah, this one, ma'am. This one, just after this question, 1.2. Yeah, this one, ma'am. 1.2. This one, I guess. After this, ma'am. Yeah, this one, ma'am. This one. Yeah, ma'am. The D option, I'm not understanding. Like it's not
D or
clicking.
D?
D1, ma'am. D for dog. Yeah.
Okay. So why this is the maximum degree you are asking?
Yeah,
Out of
kind
this
of.
given option, this is the maximum possible degree for R of x because obviously
Yeah,
it cannot be equal to degree of P of x and
yeah,
Q of
yeah.
x. First, that is clear, right?
Yeah,
And
that is clear. Yeah.
okay. Then why it is degree of Q of x minus 1? Okay. Now let us say that. Okay. So let us say that. Okay. So how can I explain this in some other example, some simple example where you can easily understand? I'm thinking.
Maybe you can give you can give it an
Yeah,
instance.
just give me a minute. I'm trying to think. Let us say that you have a box. Okay, you have a box, and you in that box. Okay, so let's say that in that box, the maximum number of chocolates you can have is this degree of. What is the maximum number of chocolates you can have? That's what I'm talking. Degree of R of x is what I'm talking. Now, what I know is that the number of chocolates which Q of x have is always less than or equal to the number of chocolates which P of x can have. So, how many can R of x hold? Whether it can hold the number which Q of x holds or P of x holds. Which one can it hold? Maximum. Definitely only this much, right? It cannot hold more than this. I don't know whether I
You
gave
can
up
use
correct.
the equation of P of x is equal to Q of x into quotient plus R. So if you see left hand side and
Maybe
right
some
hand side,
specific
the
example if I do, will
degree,
it be clear for you? Should I do
Yeah,
with a specific example maybe?
yeah, ma'am.
See, take an example where your Q of x is strictly less than Q of x. That's all you need. So let us take, so you want, let us say Q of x, I want to change my color here. So let us say your Q of x is very simple example we'll take. Q of x is, let us say, x cube. Okay, and let us say your P of x is maybe x squared. I will take very simple things only will try. X squared and x cube. Now, what is the degree of Q of x and P of x? What is the relation between them?
It's strictly qx is strictly decreasing than p of x.
Okay. Now, in this case, what is the degree of R of x? Divide it. What happens if you divide? So you have x cube, you have x square. What happens?
It's the degree. It's constant remainder. Yeah.
Sorry, something happened here. Yeah. So here what happened? Here maybe let's take, maybe I don't want the 0 case. Maybe I'll take something like this. So then what happens? I take into x, then what will happen? I get x cube and then the remainder is 1. So what is the degree of R of x?
That is 0.
Yeah. Right? And here, see, this is the maximum. How much? What is the maximum value it can take? It can take only the value of x squared. It cannot. This is the maximum possible value. See, if it is degree of p of x, already I know that the r of x is smaller than this. So this is the maximum value it can take, right? It cannot go beyond this value. Already I know that degree of r of x is less than or equal to degree of q of x minus 1. So degree of q of x is the maximum it can take. And p of x can be bigger than this. So we cannot think of something bigger than q of x, right? Already you have upper bound.
Okay,
See,
ma'am.
you are something in a situation like this. Okay. So let us say you are somewhere here. Okay. So what is the maximum value you can reach? Already you know that this is the, you cannot go beyond this point, you already know. Okay. And your degree of p of x is lying somewhere here. So whether you will say degree of p of x as a maximum value or q of x as a maximum value, you know that already this is the point where you can go. You cannot go beyond this, you already know. Degree of r is definitely less than this, you know. You cannot go beyond this, you know. So, and your q of p of x is lying somewhere. So, can you go somewhere beyond this? No, right?
Okay, ma'am.
Okay.
Ma'am, my doubt was why there is an equal to sign. What is the difference between like strictly increasing and strictly less than in q
Okay.
of x and p of x? Like why it
Okay.
is strictly less or
Okay. So, you are asking,
okay.
so the why it is not equal to degree of here, if it is less than, what difference does it make? Is that what you are asking?
I am asking that why q of x is strictly less than or it is just less than. Why there is an equal to sign? In what cases there it become equal and in what cases it becomes strictly less than or just less than?
So, here this less than became less than or equal to. How it became? Is that what you are asking?
Yeah, and why you are writing it again the second?
Okay. Okay. So,
Why did
this.
you write that?
Okay,
That
so this is possible only when we are dealing with natural numbers. If we are talking about real numbers, we cannot do this. So when we are dealing with natural numbers, this is possible. Because let us say, for example, you have numbers 1, 2, 3, 4, 5. Okay, and your degree of q of x is 5, let us say. Okay, now I am saying that degree of r of x is less than or equal to strictly less than degree of 5. So what are the possible values for degree of r of x? Tell me the possible values.
ma'am, it should be always less than 5, so 4, 3, 2, 1.
Yeah, so 1, 2, 3, 4, right? So
Yeah,
these are the possible values. So
yeah,
it
ma'am.
means I can write that this is less than or equal to 4. Yes or no?
Ma'am, why equals okay, less than or equal to 4.
Because it can take 4 also.
Okay, ma'am, okay, got it.
Okay, got it?
But what was your point when you're saying natural number and real number? The second
Yes,
one is for real
yes.
number. Yeah.
Because see, this I'm able to write because they are natural numbers. Suppose it
Okay.
is real number, so I'm having an interval. So let us say the same in an interval instead of just those numbers. Suppose I'm in an interval. If I'm writing 5 minus 1, then I'm leaving out all these numbers here, which I cannot do in the case of real numbers. I have so much numbers between 5 and 4, right?
Mm-hmm.
So in that case, I cannot do this. Okay, because I'm dealing with natural numbers, I'm able to write like this. If it is real numbers and I'm writing it is less than or equal to 4, then it's wrong. Strictly less
Okay.
than 5 means it is, there are so many options here. I cannot say that it is less than or equal to 4. No, it will be wrong. Clear?
E-
See, here if it is less than 5, it can mean that it is 4.5 also. If I'm saying it is less than or equal to 4, then it's incorrect, right? Because 4.5 is not less than or
Mhm.
equal to 4.
Okay.
Okay? That's why I said that because it is natural number, we are able to do this.
Ma'am, but in the second line, you made an equal to sign also. Rx less than or equal to qx minus 1.
Yes.
Why you put that equal to sign in the downward equation and not in the above equation?
Here it is strictly less than and here it is less than or equal to, right?
Okay. Because you
Because
put
because of this, see, degree of r of x cannot be equal to q of x. What happens? See, this is your q of x, right? So this is your q of x. Suppose if you are having a polynomial where the degree is equal, then what will you do? You will again do the calculation and reduce it further, right? So always the degree of r of x is strictly less than the degree of q of x. Okay.
okay, ma'am.
So that's why here strict inequality. Now I want to understand what is the relation between q of r of x and q of x minus 1. Here it cannot take the value of q of x, but it can take q of x minus 1. So I am taking less than or equal
Okay.
to degree of q of x minus
Okay,
1.
okay. That was only a concern.
Is that clear?
Yeah, ma'am.
Okay. 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 Any other questions? All right then.
Ma'am, I have one question.
Yes.
Ma'am, the polynomial graph that we solved just now, like, ma'am, this type of graph so accurate we cannot draw in the examination hall. So, ma'am, my question is that will this graph drawn in the question so that we can answer the options, or we have to draw such a complex graph over there?
See, you don't have, that's what I said, you don't have to draw this much accurately to answer the question. This much is enough to answer the question, and only this much you can do with this information. Suppose if you want to precisely draw all this, there is too much work involved in that, and that is not expected here. Okay.
Okay. And ma'am, that for the option D, like we can see that from option from x equal to 8, it is going to negative infinity. So from the y-axis, it will cut only once. That's why it's 1, right?
Not y-axis. For any horizontal line, it will cut the graph at one point. That's why it's 1 to 1. Yes.
Okay. Okay. Thank you, ma'am.
Yes.
Ma'am,
Yes.
ma'am, I have a doubt. How do we make graphs? Like I'm having trouble in making them.
Okay. So, did you listen to these points which I mentioned? Try
Yes.
exactly the same things. First, look at what happens at the end points, end behavior. Then look at the roots, and out of those roots, check for turning points. With this information, you exactly maybe take this particular example itself to try the same. Okay, you will definitely be able to figure out a rough graph with exactly the same steps we did here. Okay, try it out. Definitely you will be able to do.
Okay, ma'am. Thank you. Thank you, ma'am.
Any other questions? Okay, someone is asking for this PDF. Okay, let me just share it here itself. Just give me a minute.
Excuse me, ma'am.
Yes.
Ma'am, how to decide a function is increasing or decreasing based on plotting the graph?
Okay, so for let me just share this PDF. Okay, so I have shared the PDF. Please check whether it is the correct one. Yeah, you got it right.
Yes, ma'am, got it.
Okay. So from the graph, how do you see? It's very easy, right? See, for example, where is that increasing, decreasing? But yeah, so maybe here I have some space, so I'll do it. So look at this function. Something like this. Okay, going up, down, and then like this. Okay, something like this is there. So this is the graph. Now you can clearly see that. So let's take these points. So within this particular interval, what happens to the function? It's going down, right? It's going down. So it's decreasing. And what happens from here to here? The function is going up. So increasing. Okay, geometrically, it's only this much. Nothing more than this. Understand?
Okay, ma'am. Thank you so much.
Yeah. See, solving word problems right from school days, everyone have a fear, right? Oh, word problem, so difficult, right? Nothing to worry like that. Just break down into small sentences. Try to write them in mathematical terms. If you have the mathematical terms, then it's not a word problem anymore. It's just a usual problem and then solve it. So first try to, even a small sentence, how much ever you understand, only till that part you try to write it as equations or the mathematically like a set or equation you write. Okay, so maybe say let A be the set of all natural numbers divisible by 2. If it is given like this, try to write it as a set. Or if you are say that f of x is a function which has roots at 2, 4, 8, then try to write it as f of x is equal to x minus 2, x minus 4. So whatever is given, try to express it as express it mathematically. Okay, every single small part, express it as mathematically. And then first, always, if you have difficulty in word problems, try to write what is given, what is to find, and what are the formulas you need to find this. Right? These steps definitely you will be able to solve word problems. Okay, try this technique. Okay. All right then. So I guess I have tried to answer all your queries.
Ma'am, the PDF you are providing is not come with the solution that you are writing.
Is that so?
Yes, ma'am. It is only it has only questions.
Hmm. Okay, so let me stop sharing and send it again. Let me check that. Hold on.
Ma'am, solutions are available, ma'am.
It's there, right?
Yeah, it's there.
I guess you need to open with the maybe a different application and try it. Okay.
Okay, ma'am.
Some solutions are there in your PDF, what you have shared.
Ma'am, I think the my PDF reader is not working
Yeah,
correctly.
try it with a different application.
Okay, ma'am. Thank you,
All right.
ma'am.
See you all in some other session. Thank you all.
Ma'am,
Ma'am,
will
I
you
have
be
a
taking the
question.
next session?
Yes.
Ma'am, when will the week 5 start?
Week 5 will be released on week 5 Saturday, right? Already released on last Friday.
Oh, ma'am, the content is released, but like a lecture, instructor session or TA session.
I guess it will be after quiz 1.
Okay, ma'am.
Ma'am, for qualifier only week 4 the syllabus is there or week 5 is also there?
Sorry, what?
For the qualifier exam,
Hmm.
the quiz, the portions are till week 4 or week 5 also?
Week 4, week 4.
Okay, thanks, ma'am.
Ma'am, for
Yeah.
the foundation level, it will come only 4 or with 5 as well?
4, 4.
Okay.
Which one?
And pattern will be same or different for the foundation?
Usually it's same only, right?
Oh, okay.
All right.
Ma'am, quiz will be on 26th October for this term.
Yes.
Okay,
there is
so the syllabus will be that including this we are that up to week 5 or
Which one? It's up to week 4, right?
Thank you.
Yeah.
ma'am, there is one
Thank
one
you,
thing
ma'am.
I
Bye.
wanted to ask to you.
Yeah.
Ma'am, when we draw a graph, if the multiplicity is coming even, what we can comment on that graph?
What do you mean by multiplicity? You mean the roots are complete? Roots are like repeating twice.
Yeah, twice or 4 times.
Okay, so what about maybe try to draw some simple graphs. Maybe let's say that you have something with power 2 and then with power 4. Try to draw, maybe first try x power 4 or x power 2. Try those and see what happens.
Yeah,
Ma'am,
ma'am.
when we like x to the power 4, like when we are trying to draw that graph, then what happens is from the x square graph, that parabola will be much more like spread out.
You see, here
That
he is
thing.
just asking about the turning point. If you are talking only about turning point, then it's not going to make any difference whether it is square or 4, right?
Yes,
No,
ma'am, but it will be spread out.
I am saying if the multiplicity is even, ma'am.
That's what
Like,
I'm saying. That's what, if you are having even multiplicity, it's not going to make any difference, right?
then there will be at least one turning point, na? The
Yes,
turning
yes.
point should be there. But
Yes.
if the multiplicity is odd, like 3, 6, like 3, 5, then we cannot say that there is a turning point or not. But
Yes,
if it is an even,
we cannot say the turning point.
yeah, only when it is even, the multiplicity of the roots are even, we can say that.
Yes, yes. Okay. All right.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Ma'am, you are going to take the next session also, or the other teacher will going to take it?
I don't have much idea. So week 5, most probably I will not be taking, I guess. Okay. Thank you. Bye.